Hey everybody. Today we're talking about the mean, variance, and standard deviation of continuous random variables. Let's start with the mean, also known as the expected value. If x is a continuous random variable with PDF little f of x, then the expected value of the random variable is just the integral of the values that the random variable can take weighted by the probability density. Formally, integral from negative infinity to infinity x times f of x dx. This formula closely parallels the definition for the expected value of a discrete random variable, where we take the individual values, multiply by their probability, and add everything up. In either case, your intuition should be the same. We're talking about a weighted average of all the possible values that the random variable can take. Let's do an example. Consider a random variable x with this PDF. F of x is 1 minus 1/2 x from 0 to 2, and 0 otherwise. So the support of this random variable is 0 less than or equal to x, less than or equal to 2. Notice that this is a legit PDF. The PDF is always positive, and its integral over all possible x values is exactly 1. Okay, let's compute the expected value. Let's compute the mean. Here's the formula from the previous slide. Next, I'm just going to plug in and replace the limits of integration, negative infinity to infinity, with 0 to 2. This function's 0 outside of that interval, so we really don't need to consider any other x values than this. We multiply that x through, anti-differentiate, and then plug in the limits of integration to get 2/3. The expected value of this random variable is 2/3. Visually, there's a pretty simple interpretation of the expected value of a random variable. Here, I've sketched the PDF on its support, so from 0 to 2, and shaded in the area between the PDF and the x-axis. The expected value is the balance point of this shaded region, and that's always the case. All right, now let's do variance. Again, the formula for variance looks a lot like the formula for the discrete case, but with the summation replaced with an integral. The variance of a continuous random variable x is given by the integral from negative infinity to infinity x minus mu quantity squared times f of x, where, again, mu is the expected value and f of x is the PDF of the random variable x. Now this is great as far as it goes as a definition, but there's another form that's more frequently used. And to get to that, we take the x minus mu, FOIL out that square, distribute the f of x and break up the integrals, and then notice that the middle integral is just a formula for the expected value of the random variable x. So really that whole middle term is just negative 2 mu squared. We can simplify those last two terms, and then, if we like, replace mu with the terminology expected value of x. That gives us this formula. The variance of a continuous random variable x is given by the expected value of x squared minus the expected value of x, quantity squared. By the way, this calculation can be carried out in exactly the same way for a discrete random variable, just with summations instead of integral signs. This is the formula we typically use to compute variance. The standard deviation, sigma sub x, of course, is just the square root of this. All right, let's go on with that previous example. Same PDF as before, same random variable. And now let's get the variance and standard deviation. We've already determined that the expected value of x is 2/3. So using that last formula from the previous slide, all we really need to do in order to get variance and standard deviation is to compute the expected value of x squared. So I'm going to do the integral from negative infinity to infinity of x squared times f of x dx. Again, I can restrict my attention to the interval from 0 to 2 because the PDF is 0 elsewhere. In other words, I can just restrict my attention to the support of the continuous random variable. Again, I distribute, anti-differentiate, and plug in the limits of integration. Again, in this case, coincidentally, I get 2/3. And I can use this now in that formula. Variance is expected value of x squared minus expected value of x squared to plug in and get overall a variance of 2/9. Taking the square root of this, I get a standard deviation of the square root of 2 over 3.